Good morning, 8th grade. Today's Tuesday, April 7th, and we are starting a new lesson. So let's see how this works out today. I have my phone on its stand, and we're going to see how this video goes through. So factoring quadratic graphs. This is in the algebra book that I have, so this is not in your books. You can't use your website or anything like that today, your McGraw-Hill website. So just pay attention. I'm going to try to make this as quick as I can. I don't really think you guys want to watch a 30-minute video of me, but so I'm going to try to explain this quickly and thoroughly. So exploring quadratic graphs. We did quadratic graphs in chapter 4. It's the graphs that form a parabola. So they're not, excuse me, they're not straight lines, not linear equations. So your graphs, I'll put this in here. Your quadratic functions are going to look like this. They're written in this form. So y equals ax squared plus bx plus c. This is called standard form. Today we're just going to be focusing on the y equals ax. So the y equals the a value of a, the coefficient that affects in front of the x squared that affects the width of the parabola. So we'll get more into that. So a lot of our equations today, it's just going to look like y equals 5x squared, or we're also going to be working with equations ax squared plus c. So y equals x squared plus just a number. So here's some quick definitions, and we'll get into each of these as we get through the notes. So a parabola is the U-shaped curve that is the graph of a quadratic function. The axis of symmetry is the line that divides a parabola into two matching halves. I'm going to have this sheet in my blog today, guys, so you don't need to worry about filling this out. It's going to be filled out for you. The minimum is the y-coordinate of a vertex of a parabola that opens upward, and the maximum is the y-coordinate of the vertex of a parabola that opens downward. So let me show you what I mean with that. So here's a couple of examples of parabolas. Identifying a vertex. So in order to identify the vertex of your graph, you need to tell if it's a minimum or a maximum. So this graph is opened downward. So this graph has a maximum. So this is the vertex, and then you just need to find where it lies on the coordinate plane. So over 1, up 2. So the vertex is at your x is 1, your y is 2. So 1, 2, and it has a maximum. This one is opened upward, so it has a minimum, and the vertex is at positive 2, negative 4. And I just made these dashed lines. These are your axis of symmetry. So it goes right through the vertex. Let me go ahead. So really quick, so if these were an equation, so your a, if your a is a positive, the parabola opens upward. So this a was a positive number. It opens upward, and it has a minimum. So this a in this equation, y equals ax squared, was a negative because it opens downward, so it has a maximum. So we'll get more into that in the next page. Let me show you an example of this. So in order to graph quadratic functions, we make a table, just like we did in chapter 4. So this table was already made. It has a list of your x's, so 2, 1, 0, negative 1, negative 2. You just plug it into the equation. So I plugged it into this. 3 times 2 to the second is 12. 3 times 1 to the second is 3. And then you graph it. So this one is done in the pink pen. So as you can see, in this equation, it's y equals ax squared. So the vertex is right on your origin, right at 0, 0. Whenever your equation looks like this, your vertex will always be on your origin. For this equation, this c right here, the number after the ax squared, that determines where your vertex is going to be. So this was 3x squared minus 2, so it brings your vertex down to negative 2. You would be able to know that anyways, because when you're graphing it, so 2, you'd plug it in, 2, 10, it just does it automatically. So here we go, a couple more examples. Identify the vertex of each graph, tell whether it is a minimum or a maximum. So this one, 4, 3, it has a maximum. This one, -3, -3, it has a minimum. So we're going to be doing that on our homework for today. Let me go back into the book right here. It's kind of just going over what we just did, but just to make sure that we all have an idea. Again, here's a couple more examples. Identify the vertex of each graph, tell whether it has a minimum or a maximum. So this one, the vertex is right here. It is at 1, -2. It has a minimum. And then for this next one, this vertex is at, it looks like -2, +4, right here. If I wanted to do a line of symmetry, I would just go down like that. It has a maximum. So graphing, I know we just went over an example on our paper, but here's another example, graphing this type of equation, y = ax squared. So we know right away the vertex is going to be right at the origin, right at 0, 0. And then you can make a table, make a table of values. And what we can go over today, so as you guys can notice here, x only has 0, 2, and 4. There's no negative numbers. So this might make it a little bit quicker for you guys in the homework. You can just choose 3 positive numbers, 0, 2, 4, or you can choose a couple negative numbers. It doesn't matter, because when you graph them, you can just find the corresponding points on the other side of the axis of symmetry. So for example, for these 3 points, if you plugged them into the equation, 0, 0, you're right there. 2, 2, so right here. Oops. 4, 8, you're right here. Then how did I get these points on this side? Well, I found the corresponding points on the other side of the axis of symmetry. So the other side, you'd be right here. You'd be at -4, +8. And then the other side of the axis of symmetry, you'd be at -2, +2. And then you draw your parabola. Notice that my a value, right here, 1/2, is positive. So my parabola is opened upwards and the vertex has a minimum. So if we graphed this one, your a is a negative, so your parabola would be opening downwards. It'd look like this. Your vertex would have a maximum. One more thing I want to go over. So the value of a, the coefficient of x2, so the value of a in this equation, y = ax squared, it affects the width of the parabola as well as the direction it opens. Well, we already know it affects the direction it opens, because if it's positive, it opens up. If it's negative, it opens down, but it also affects the width. So look at these graphs. This is your a, 4, 1/4, 1. As you guys can see, the less so a 1/4, the parabola is wider. So as it gets greater, as your a gets greater, so now your a is at a 1, your parabola gets a little bit more narrow, and now your a is at a 4. Look how narrow your parabola is. So as a increases, so 1/4, look how wide the parabola is as it increases, because now it's at 4, your parabola, the width of it gets narrower. And for this example, order the quadratic functions from widest to narrowest. So the widest would be the